All right, you guys, today we're doing a little mixed review with the law of sines and the law of cosines. So here in our first instruction, I'm saying use either the law of sines or the law of cosines to write an equation and solve for the missing side or angle measure. If the triangle is ambiguous, provide both measures. Round all intermediate steps to the nearest 10,000th, so 4 decimal spots. All right, so before I even get started, we want to think about when do we use the law of sines versus the law of cosines. So the law of sines, we can only use it when we have an angle with an opposite side. So anytime we have a diagram that has 2 angles and a marked side, we're good. Because if we know 2 angles, we obviously know the third. So we will always have an angle with the side opposite. If we have that side-side angle combination, we're good. We can use the law of sines. We have an angle with the side opposite, but with side-side angle, we know that that is the instance where we have the potential for that swinging door effect, which is the ambiguous case. And we know that that occurs when the side opposite the given angle is smaller than the other given side. If we don't have an angle with the side opposite, we got to use the law of cosines. So that shows up when we have side, side, side. We're able to solve for a missing angle. And if we have side, angle, side, we can solve for a missing side. So we have options, but we just have to know how to attack each type of problem. All right, let me zoom in a little closer so you can see problem A. All right, so problem A, we see 2 angles and we have a side. Technically, we start with ASA. And since we know 2 angles, we obviously know the third. We can solve for it. So that missing angle here would be 64. All right, so since we have an angle with an opposite side, we use the law of sines. And when I build my proportion, I can say that sine 74 is 2x. I'm always looking at the angle and then the side opposite. So sine 74 is to x, just as sine 64 is to 3.3. So now I have a beautiful proportion. I just have to cross multiply. So x times sine 64 equals 3.3 times sine 74. And then both sides I'm just dividing away the sine 64. All right, so now I just have to crunch it. And this here, again, I'm saying go to 4 decimal spots. All right, so here we go. We just slide over so we can see it side by side. All right, 3.3 times sine 74. Every time I open parentheses, I'm going to close them and then divide away the sine 64. All right, so right here I get my answer. It's about 3.5294. And again, it's a rounded answer to 4 spots. That's your nearest 10,000th. So 3.5294. All right, next up, second example. So here, looking at what is marked, I see 3 sides. I have 3 sides marked and I want an angle. So right now I have side, side, side. In order to use the law of sines, I need an angle with the side opposite. I do not have that here. I only know all 3 sides. So that means I'm using the law of cosines. All right, so to remind you of that rule, let me write it out first. A squared equals b squared plus c squared minus 2 times b times c times cosine A. And whenever we're solving for the law of cosines, we are either solving here for a missing side or here for a missing angle. And these are always in opposite positions. So in this instance, I'm solving for an angle. So I'm solving for this part right here. And my side opposite is the 3. So I'm very conscious of the angle and the side that is opposite right there. So that 3 is going to go in right here. Okay, where the 4 and the 4.6 go, it doesn't matter. We have options. We can call that B and that C, or vice versa. So let me go ahead and plug in. So 3 squared equals 4 squared plus 4.6 squared minus 2 times 4 times 4.6 times cosine x. So again, that's what I'm solving for. I'm solving for the angle measure that is marked x. So now it becomes an algebra problem, and I have to get that cosine x part by itself. All right, so here I have 3 squared. I got to do that part first. So here I'm looking at 9, and that is equal to 16 plus 4.6 is 21.16. Okay, 2 times 4 times 4.6 is 36.8, and then cosine x. All right, so I keep working the problem. I got to make sure I follow my order of operations. I can only consolidate the like terms. So here I have 9 equals. I can combine right here to 37.16, and then minus 36.8 times cosine x. So I can't combine any further because right here, this is a package. This is a product. These are being multiplied. So I'm trying to get this part by itself. So I need to go ahead and take away the 37.16 from both sides. So I get negative 28.16 is equal to negative 36.8 times cosine x. All right, so I'm getting closer to getting that cosine x part all by itself. My next move, I have to divide out that negative 36.8. All right, so now I just need to crunch. What is negative 28.16 divided by negative 36.8? Okay, and I'm taking that ratio to 4 decimal spots. So right now then, I know that cosine x is about 0.7652. So if I want the angle measure, then I'm going to plug in inverse of cosine with the ratio of 0.7652, and that's going to pump out the angle measure to 4 decimal spots. And again, I'm just building off of rounded intermediate steps. Let me make sure we can see it all. Let me slide it over. Okay, so second cosine, 0.7652, and then I close just like so, and that gets me about 40.0752 degrees. So again, I am building off of rounded intermediate steps. All right, we should be good there. Okay, let's look at C next. All right, so looking at C, what's marked? So I can see that I have 2 sides marked, and I do have the included angle. So I'm given side, angle, side. All right, so here, since I don't have an angle with an opposite side, I have side, angle, side, I have to use the law of cosines. So let me just remind you again, a squared equals b squared plus c squared minus 2 times b times c times cosine a. And again, we're either solving for a side or an angle. And in this case, we're solving for a side, right? We're solving for x. So we're solving for a side right here, and the angle that is opposite that 46-degree measure is going to go right here. What we call A and B, or I'm sorry, not A and B, B and C, it doesn't matter, right? They're both 5 anyways. So when I plug in, I should have x squared equals 5 squared plus 5 squared minus 2 times 5 times 5 times cosine 46. This is our easier variation for the law of cosines. All right, let me slide it over and then type that in. So here I have 5 squared, so 25 plus 25 minus 2 times 5 times 5 times cosine 46. All right, so I know that x squared is approximately 15.2671. Let me just transfer that. So 15.2671, and then I can solve by taking the square root. Now algebraically, that gives me a plus or a minus. So square root, there's my square root button, 15.2671, and that's going to get me about 3.9073, plus or minus. Now remember, it represents a measurement, so I'm really only interested in the positive. So my final answer is just the positive 3.9073. Now, there may be something else that you noticed. There is actually a shortcut in this problem that some of you may have seen. So I want to show you the other pathway through it. Is to see, well, this is an isosceles triangle. And I know that because I have 2 sides that are the same. So that means the 2 base angles would have to be the same also. So let me sketch it out one more time. So here's 46, here's 5 and 5. I ultimately want x. So now, again, those 2 base angles, they have to be the same. So all I'm doing is I'm taking the remaining 134 degrees and splitting it 2 ways. So this would be 67, and this would be 67 degrees also. So then I have an angle with an opposite side. I could use the law of sines. And if I did it that way, I could say that sine 46 is to x, just as sine 67 is to 5. Okay, cross multiply from here. So x times sine 67 equals 5 times sine 46. And then I'm just dividing each side by the sine 67. So let's confirm that we get that same answer right here. All right, so 5 times sine 46 divided by sine 67. Well, looky there, we get the same answer, right? So just confirms that sometimes there's multiple pathways through problems, and I love showing you those different routes you can take because ultimately it doesn't matter to me. I just want to make sure that we get to the same end result. All right, next one over here in D. So looking at this problem, I can see that I have 2 sides and 1 angle, but it's not the included angle. So I have side-side angle. So side-side angle, right? I have an angle with an opposite side, angle, opposite side. So I'm using the law of sines. But the thing I have to ask myself, because I know this only happens with side-side angle, is the triangle ambiguous? So if it is, where would be the hinge? Right here. The hinge would be right in between the two known sides. Okay, so now I'm looking at the angle and the side opposite right here. And I'm looking at what is the measure of this side in relation to the other marked side. And I can see, oh, it's less, right? It's smaller. So what happens then is that I do have that swinging door. That 2 has room to swing into an alternate position right about here. So that would be my alternate position. So we're going to say, yes, this triangle is ambiguous. We know that the side opposite that given angle is smaller than the other given side. So when we have an ambiguous case, there's 2 very different looking triangles that could emerge. So I could have a triangle that looks like how the problem started. Let me just redraw it, where this is 2, this is 3, this was 39 degrees, and this was x. Sometimes I call it theta. Okay, or right, this side could swing in a second spot right here and look like that triangle. So let me draw that out also. So here would be 2, here would be 3, here's the 39, and here's the other option for x. So let's go ahead, let me slide that up. Let's solve for case 1. So this one right here. All right, so from here, I can say that sine x is to 3, just as sine 39 is to 2. Okay, cross multiply. So 2 times sine x equals 3 times sine 39. And then divide each side by 2. So sine x will be about. All right, let's plug that in. So I'm looking at 3 times sine 39, closing my parentheses and dividing by 2. So I get a ratio of about 0.944. So inverse of sine with that ratio is going to give me my first possible angle measure. So second sine 0.944, and we get about 70.7345 degrees. So my first option would be the angle that's right here. So 70.7345 degrees. Let me draw it in right here too. Okay, so that's what it looks like in the first triangle. But what you have to remember, if this door, right, if this side swings into this position here, I also have a 2 right here. So the angle that's 70.7345 right here is also right here because they are isosceles, right? It's that isosceles triangle. Those base angles are congruent. So it's really imperative that we see that this is an isosceles triangle with those congruent base angles. So those base angles have to be the same. So if this angle right here is 70.7345, then I need this angle right here, its supplement, because together they form a linear pair. So I need to do 180 take away 70.7345 for my second option. So here I can do 180 take away 70.7345, and that gets me another option of 109.2655. So when I state my answer, I really have to say both of them. They are both possible answers because this angle right here could be 109.2655 approximately. All right, so the measure of x could be 70.7345 or 109.2655. Okay, so again, we know that the ambiguous case only happens with side-side angle, and it only happens when the side opposite that given angle right here is smaller than the other given side. It gives it room to swing into a second position. Once we solve for that first possible angle measure right here, when this door swings right here, those two angles have to match. Those two base angles have to match. So the one in my second possibility is the supplement of the first. So 180 minus what we solved for initially. Those are both our possible angle measures when it's an ambiguous case. All right, let's do a little flip to the back. Let's look at some word problems. Let me zoom out a smidge. All right, so I'm saying this is mixed word problem practice. Use any strategy to solve. All right, so we are on a baseball field. So on a standard baseball field, the bases form a square with 90-foot sides. So often we call it a baseball diamond, right? But it is a square. So technically it is a square. We just look at it rotated like this. Okay, so here is our square, our baseball diamond, right? We use that interchangeably. All right, so we know that each side is 90 feet. So I'm going to label 90 for all three sides. All right, so here would be home plate. For those of you who don't know baseball, here's home plate. Okay, and then as I wrap around, here would be first base, here would be second, and here would be third. All right, we're told that the pitcher's mound is 60 feet from home plate on a diagonal from home plate to second base. So we're looking at this pathway right here that connects, and we know that the pitcher's mound is a little bit further in, right about here. Let me shade it, make it look pretty. And we're told that that's 60.5 feet along that diagonal pathway from home plate. So this is my 60.5. All right, so we're asked to find the distance from the pitcher's mound to third base. So if I draw that in here, that is what I'm solving for, so that's what I'll call X. So let me look at that triangle off to the side. Right, it looks like this right now, where this is 90, this is X, and this is 60.5. Now I need an angle. I know I need an angle, and I'm not explicitly given one, but I should know what one is. So if it's a square, I should know that all of my angles are right angles. And if I'm looking at this pathway from home plate to second base right here, I'm really splitting my square into two congruent 45, 45, 90 triangles. So here, if I look at this right angle, and I connect through, right, I'm splitting into 45 degrees. So I'd have 45 degrees here and here, but this is the one that I need because it gets me inside of my triangle. All right, so here's my picture. This is what I'm trying to solve. The distance from the pitcher's mound to third base. So what do I have marked in my picture? I should notice, oh, we got side, angle, side. I do not have an angle with an opposite side, so I have to use the law of cosines. Okay, let me write that out for you one more time. So a squared equals b squared plus c squared minus 2 times b times c times cosine a. And again, we're either solving for a side or an angle, and those are always in opposite positions. So here I'm solving for a side. This is the easier variation. I want what's in this position right here. So when I plug in, I have x squared equals, again, what I call b and c, it doesn't matter. So I could say 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine 45. Slide that over. All right, so I can type all of that into my calculator. Let's do so right now. Slide it up. All right, so 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine 45. All right, so now x squared is about 4,059.8572. So again, I'm just rounding all those intermediate steps to the nearest 10,000th, 4 decimal spots. I want to solve by taking the square root. So second square root right there. So second right here, the x squared got me the root. And I'm plugging in 4,059.8572. I know that technically, algebraically, that's giving me a plus or minus. So 63.717, but I can only take the positive because I'm looking at an actual distance from the pitcher's mound to third base. So I would get my final answer as about 63.717 feet. All right, moving on to the next problem. Let me slide this up. All right, you build a triangular garden. The sides of the garden are 7 feet, 10 feet, and 12 feet. What is the area of the garden? Let me give you a nice little hint. Let me draw this at the top. Hint. Make the long side the base. It just makes it easier to picture. All right, so let me draw myself a visual. So my longest side here is 12. So I'm going to make that my base. So here is the 12. Okay, I have a side that's 7 and 10. So let me draw that in just to give myself a visual anchor. I know that this is not to scale. So 7 and 10. All right, so now I'm trying to find the area of the garden. So I need to eventually, if I make this the base, I need to figure out what that height is, right? The measure of the altitude that would connect. But in order to get there, I need to have an angle first, right? I can't automatically jump to get to this segment's measure first, right? I don't know if this is a right angle or not. It's not stated to me that it is, so I can't make any assumptions. So let's start by finding an angle. Let's find this angle, what I'm calling x. So if I write this out as a series of steps, I'm going to say find the angle first. So find angle X. Okay, so if I look at what I have marked, I have three sides. I have side, side, side. So I do not have an angle with the side opposite. I have to use the law of cosines. All right, so let's write that out one more time. So a squared equals b squared plus c squared minus 2 times b times c times cosine A. And we're either getting a side or an angle. And in this case, we're getting an angle, so we're solving for this part right here. All right, so plug it in. So what's opposite the x is the side that's 10. So I have 10 squared over here equals 7 squared plus 12 squared minus 2 times 7 times 12 times cosine x. So now I have to do a little work to get to the cosine x all by itself. Okay, so now if I clean this up, I see, okay, that's 100, and that equals 49 plus 144 minus 2 times 7 times 12, so 168 times cosine x. Okay, I'm working to get this part all by itself, so I can consolidate right here. So 100 is equal to 193 minus 168 times cosine x. All right, from here I can deduct the 193 from both sides. So negative 93 equals negative 168 times cosine x. Still working to get that cosine x by itself, so from here I can divide away the negative 168. So when I crunch that, so here I have negative 93 divided by negative 168, and we get a ratio of about 0.5536. So cosine x is about 0.5536. So inverse of cosine with that ratio will get me my approximate angle measure. So second cosine, 0.5536, and we get an angle measure of about 56.3857. So 56.3857 degrees. Let me add that to my picture right here. So 56.3857 degrees. Okay, phew. So building off that, well, I need to figure out, well, what's my height? So let me draw that in. What's my height? So that perpendicular segment that connects a base to a vertex, that's the altitude. We want its measure. So we want to next find the height. And now that I have that angle in place, right, I can use basic trig. I'm going to call the height y. So let me look at it like this, roughly, little sketch. So the angle right here is the 56.3857 degrees. Y is the height that I want, and I know the hypotenuse here is 7. So here I have a right triangle. So from this vantage, the angle I just solved for, this is opposite and hypotenuse. So I can use my basic trig. I can go back to SOHCAHTOA. The one thing that I noticed that students try to do once we've taught the law of sines is students try to make everything the law of sines. But if it's just a right triangle, we can absolutely go back to basic trigonometry, just SOHCAHTOA. So we know that we have sine because we have an opposite and a hypotenuse. So here I know that sine 56.3857 is equal to y over 7. I'm going to visualize that as a proportion, cross multiply. And y equals 7 times sine 56.3857 56.3857. All right, let's crunch that. So 7 times sine 56.3857. Okay, and that's going to get me a height of about 5.8295. Let me add that to my picture. So right here, 5.8295. All right, so lastly, I'm all ready. Let's get our area. Area, well, it's a triangle. So if I want to find the area, I know it's 1/2 the base times the height. 1/2 base times height. So half of 12, and the height that we just solved for was 5.8295. All right, so now I just have to multiply across. So half of 12 times 5.8295 is going to get me an area, my final answer, there was a lot of work to get to it, of 34.977, and we're looking at square units. And I actually told you the units were feet, so I will say feet as well. So square feet. Now in this problem, I was building off of all rounded intermediate steps to the nearest 4 decimal spots, the nearest 10,000th. All right, got one more problem. One more. All right, we have Anne and Brenda who walk along lines that form a 63-degree angle. Anne walks at 3.5 miles per hour. Brenda walks at 3 miles per hour. How far apart will they be in 4 hours? Okay, so let's see. Let's draw a little path for Anne and for Brenda. All right, so we know that there's 63 degrees between them. Let's make this Anne's pathway and this Brenda's pathway. I'm not scaling it perfectly, but I need to read the information back one more time to do that. So we're looking at how far apart they are in 4 hours. So they both start from here. Anne is walking this way 3.5 miles per hour. So 3.5 miles per hour after 4 hours, if I multiply those, is 14. So she's walked 14 miles in 4 hours. Brenda's rate is 3 miles per hour, so in 4 hours she's covered 12 miles. So Anne should just be a little bit longer than where Brenda is for my drawing. Okay, I want to know how far apart they are in 4 hours. So if I connect over here, now I have a triangle, and that's what I want to solve for. So what information do I have right now? What is given? I have side angle side. So I do not have an angle with a side opposite. I gotta use the law of cosines. All right, so laying it out one more time. A squared equals b squared plus c squared minus 2 times b times c times cosine A. And we know that we are either solving for a side or an angle, one of the two. And in this one, it's the easier of the two variations because we're solving for a side right here. All right, so plugging in, I get x squared equals 14 squared plus 12 squared minus 2 times 14 times 12 times cosine 63. So let's type all of that in. All right, so 14 squared plus 12 squared minus 2 times 14 times 12 times cosine 63. All right, so here we go. So x squared is about 187.4592. And I want to solve by taking the square root. So 187.4592. I know that technically that gives me a plus or minus 13.6916, but it's a distance between two people, so I'm only looking at the positive. So I get about 13.6916 miles. All right, that's all I got for today. Have a good rest of your day.